We are going to look at Darwin's theory of evolution, part one. The theory is based upon a few different other ideas in science, the first being the theory of plate tectonics. This explains how the surface of Earth it's made of plates that move due to convection currents in the mantle. So the very inside of Earth is solid. Another layer is molten. It's so hot, liquid, you don't want to touch it. Then you have the mantle, which is represented as red. That is where our lava comes from when there's a volcano. So again, very hot, molten material. So that's all moving around due to the heating and cooling, just like air moves around on Earth. So the plates are actually shifting on top. So things like the Himalayas in India are actually growing, they're getting taller, and the Atlantic Ocean is actually spreading because there's a ocean ridge, an ocean trench in the middle that's spreading apart. So all of these ideas are used within the theory of evolution to explain how things have occurred. Because of how the plates are moving, there is another theory called Pangea. So they believe, based on the movement currently that's been recorded, that Earth, if you go backwards in time, all of the plates actually connected as a master continent. They actually fit together like puzzle pieces, taking into account a little erosion along the edges. So it's very interesting. And that plays into ideas of where certain fossils are. So if you took the continents South America, Africa, Antarctica, Australia, and India, as shown in the picture, if you put them together, there's actually places and strips of land where the same fossils were found. Very interesting. If these occurred separately, um, it's just a lot of coincidences. So they say that this is an example of good evidence for evolution. So fossils are the dead organisms. It's not necessarily everything of the organism. You're going to have bodies rot away, you'll have bones. The bones will actually be changed into rock or fossilized. You might have fossilized footprints, leaves of trees, depends on the conditions that the fossils were made. We might take some time to look at another website in class that shows that information. So looking at fossils, the deeper a fossil is, the more simple it usually is. This can be taken into account when you're looking at how fossils change over time. If you look really, really deep, you find very simple organisms, as you can see in the brown all the way at the bottom of this image. As you go up, they get more complex. The last bit of little background information I wanted to talk to you about is what we call hotspots. So because the plates are moving, one example, the Pacific plate shown in this picture, the plates are moving over that hot magma. And you can see that there's a little volcano appearance there. That's Hawaii. Landforms, specifically islands, are currently being made. Hawaii is growing. You can see the oldest islands are in a row going out, and you'll actually see different amounts of growth and trees and animals on the older islands. And that's taken into account when you're looking at evolution. The older islands are more evolved. Um, The theory of evolution is a description of how we got the variety of organisms. This is called biological diversity. How did we get all these different organisms, and how are they related? So we just ended talking about DNA, and now they use DNA evidence to show how we're related. We are going to see a little clip in class about the history in 24 hours. It gives you a kind of time span. So the official term evolution means change over time. The theory is a collection of scientific facts, observations, and hypotheses. So there is a theory of the evolution of the horse. The image below shows one theory. going from a very small species, similar to a very small dog, and getting larger over time to our current species. We'll talk more about that as well. So, who did all this stuff? The major credit is given to Charles Darwin. There were other men of the time looking into this. He made numerous observations and collected evidence that led him to propose his theory of natural selection. So in 1831, he was about 22 years old, a young man. He left England on the HMS Beagle, one of the Royal Navy ships, and he traveled around the world, collected specimens. He wasn't really out to prove anything. He was just what they call a naturalist. So there's the boat, and that's him as an older man in the image. So where they took off from Europe. They went south, and they went around the bottom of South America, and there you see the Galapagos Islands. So it's actually below us. Then they went around to Australia, the bottom of Africa, and then back up to Britain. So this took a long time. So what he saw there, he saw a variety of traits and methods in reproduction and where they live. The interesting thing was he saw fossils that compared to current living organisms in the area. But these organisms on the Galapagos were new. They didn't they weren't seen on the mainland. So if we go back to this picture, it's closest to South America, so the Galapagos Islands has unique animals that aren't found anywhere else. We'll talk more about those in class. So they are 1,000 kilometers west of South America. They have different climates and different organisms. Some islands are volcanic, and some are very lush greenery. There is an island where people do live. This is one of the main organisms he talked about, the Galapagos tortoise, and they have very different shells. Well, they're all shells, but they are different, and size necks. So we'll talk more about these as well. So go take your quiz on this first part.